Lesson 7, last lesson about backup and restore disaster recovery concepts. Well, we have this objective of completing this lesson. You should be able to identify the Oracle VM components to be backed up. We have Oracle VM Manager components, we have Oracle VM Server components, and we have the virtual machine, the OS components. In addition to this, we have repositories and X86 fiber channel SAN servers with the LANs. So we are going to identify all of these components. Also, we discuss the guidelines for backing up these components. Each of these previous components I explained you, any of these has to be protected, so each one has different guidelines to do so. And we perform the Oracle VM Manager database backups and restores. This is a key component in your Oracle VM infrastructure. So you will learn how, for example, we have tools to be able to implement this backup strategy, and also how to restore. And the next section is about recovery in your Oracle VM environment, different recovery scenarios for the Oracle VM Manager, the Oracle VM Server, the virtual machines, and the repositories and LANs. And the last topic is to discuss on the disaster recovery concepts, how to implement active-passive or active-active scenarios in which you should be able to protect of disaster failures. Well, in the lesson overview, we have two sections. The first section of this lesson introduces the guidelines for backing up and restoring various of these components, as mentioned before, of your Oracle VM environment. The topics in the first section include what components must be part of your backup strategy, also what elements to backup for each component and their backup frequency, and how to backup and restore these components. And the second section presents recovery scenarios for your Oracle VM environment. Well, about the Oracle VM environment, remember it comprises the multiple server components. For example, you have the Oracle VM Manager server. It's a WebLogic server with the Oracle VM Core Java application, and also you have the Oracle VM Manager database. Also a networking infrastructure. So you have network interfaces in the VM servers. You create virtual NICs with MAC addresses to the virtual machines, and also you create multiple different networks for management, for virtual machine communication, private and public interconnection. Also you create network for cluster heartbeat, for the cluster server pools, a network for live migration, and a network for storage to be able to get access to storage components for the to let you show the Oracle VM servers. The external storage, we work with NFS servers, file servers, and the SAN servers. X86 fiber channel servers are supported. And virtual machines that depend on the underlying components, much like the VM servers, to be able to be running on these servers. Also, you have virtual disks, you have LANs, they get access to this. So we have dependencies with the storage resources, and for networking to be able to create private and public networks using bridges in the Oracle VM servers. Well, about the Oracle VM components, we have our Oracle VM Manager and the Oracle VM servers. To put focus on the first one, the Oracle VM Manager, you have the Oracle VM Manager software. Remember, you use the run installer to perform the installation of this software, and it takes multiple steps. In these steps, we include the installation of the Oracle MySQL Enterprise Edition software, the creation of the MySQL Enterprise database, in which we have the OBS and the app FW schemas, which contains database tables in which we catalog the information, configuration files, you know, in the U01 IPP Oracle OVM Manager-3, for example, we have multiple directories with configuration information, and the database objects. For the database objects, we implement an automatic mechanisms to take backups for the MySQL Enterprise databases, and in addition to this, it comes with the map utility, the MySQL Enterprise backup utility, to help us to do so. Well, we use, we simplify the backup implementation with two scripts to backup the database and to restore the database that invoke this map utility in background, and also to, for example, help you to take backups manually, even knowing that also you have the backups for the database objects implemented automatically. And for the side, you have the Oracle VM servers. So as you know, we install using an ISO image, the Oracle VM server for X86 software, in which we include the Sun server and software, for example, for the OBS-agent, for the agents. Also, we have configuration files in which you have multiple locations for the Sun hypervisor configuration files, for the OBS agent configuration files. Most of them are XML or text files. Some others, as you know, are databases in raw format that in previous lessons we show you how to, for example, dump the contents to produce a human readable information. So also this information need to be protected. These resources need to be protected. You have also server pool file systems if the Oracle VM servers are part of a server pool that is clustered. These VM servers need to mount using the OCFS file system LAN that contains databases and information for the repositories, for the Oracle VM server pools, for the Oracle VM servers, and so on. And the repositories. The Oracle VM servers are able to mount the repositories, NFS server repositories or Sun server repositories, in which you have multiple resources. For example, you have the virtual machine resources, much like the configuration files and the virtual disk. And in addition to these additional resources, much like ISO images, templates, and assemblies. Well, for the Oracle VM components, continuing with more of these, in addition to the Oracle VM Manager and the Oracle VM Server, you have the Oracle VM Guest. So the Oracle VM Guest, you know, is a virtual machine that has an operating system running on this, right? But the configuration of this virtual machine is in the configuration file. You know that is the vm.cfg. Also, you have a virtual disk. These are typically .image files that contain, for example, the operating system, and in addition to this, business application software, and maybe or maybe not business application data. And physical disk. So the physical disks are LANs that you get access directly from the VMs, and typically are being used to store application data, because this kind of data requires additional performance execution or best performance execution to store or to persist the data on these LANs. Also virtual or physical disks for business applications and data, and ancillary virtual machine resources, much like ISO images, virtual appliances, and the templates. Well, about the backing up the Oracle VM Manager components, the first of these main component, the manager, about what to back up in order of importance. The first one is the Oracle VM Manager database. I showed you before that in the U01 IPP Oracle VM-Manager-3, you have the data directory in which resides this database. The MySQL server has implemented the multiple storage engines, but it works with the InnoDB storage engine to improve the performance access to the metadata information. And it's important to know that, I repeat, you have an automated process to do a show, but also you have the option to invoke manually, for example, after any upgrade that you perform or any major change. In addition to this, another component to be backed up is the entire U01 APP Oracle directory. In this directory, this is the root directory, the base directory, from which you have many other subdirectories that compose the different software. For example, you have a middleware directory, which is the WebLogic server. In addition to this, you have the OVM-Manager-3 that contains the domains, the WebLogic domain that you created with the admin server information, the admin server configuration, log files, that's right, and so on. So you see that it includes more of the configuration file, and also it contains the key stores that are for authentication with the authentication certificates, and the system disk. It's important to know that the manager has in the system disk the operating system, right, and so on. Well, obviously, we are talking about backups for data that is, for example, a tool specific for this, the map utility for the Oracle VM Manager MySQL database. And for the other component, you see that basically for the U01 APP Oracle directory and for the system disk, we speak about the file system backup. So one of the best recommendation is to use a kind of a volume manager to help you to implement the way that you create the backups. For example, as you know, we are certified to install the manager in Oracle Linux. Oracle Linux, you have the option to install the certified operating system, Oracle Linux 6, 7. And in Oracle Linux, you have the option to use the LVM, the Logical Volume Manager. This is a volume manager that you have in Linux that helps you to create volumes. After that, helps you to create, in this case, amount points on these volumes, and you have the option to include multiple disks. In addition to this, the LVM utilities, you have the option to create the snapshots. And a snapshot is a backup, so it's very easy to backup at operating system level directories and files that are contained in these directories. About the backup frequency, Oracle recommends daily full backups. Also, an automatic backup of the MySQL database is performed every day, and it usually retains up to 21 events. So it's much like to retain up to 20 backup days. And always perform additional full backups before any major changes. Much like, for example, before upgrading from one Oracle VM server software version to another. For example, you work with 3.4.2, if you, for example, upgrade to 3.4.3, or a new version that will be released in the future. Well, about backing up the MySQL database that you have for the Oracle VM Manager repository, okay, a backup of the local MySQL database is performed automatically every day, every 24 hours. Also, you have the option to initiate a manual backup using the U01 app Oracle OVM-Manager-3 OVM_tools BIM backup database application. By default, the backups are stored in the U01 app Oracle MySQL DB backup directory. You have a parameter, the DB backup. This is an entry that you have in the etc Oracle OVM OVMM file. Remember, this is a configuration file that contains exactly the entry of this default directory. So you have the option to edit if you want to implement the backups in another directory. It's very important to know that you need to implement the way to extract the backups from this directory. For example, to send to tape into tape libraries to protect better these backups. And backups are rotated to keep 21 backup events. What about restoring the Oracle VM Manager MySQL database as root? You need to stop the Oracle VM Manager services. As you know, you have the OVMM and the OVM CLI, and the MySQL database services, the OVM_MySQL service. Well, after you stop this, as the Oracle user is the owner of the Oracle VM Manager software, you use the restore database.sh command. In this case, you also specify the name of the backup directory. For example, you have this one that is, for example, each directory has auto full backup and also the date and the time at which the backup was taken. Or if you take manually also, okay, you will see exactly the same, but with manual full backup and the date and the time. In addition to this, after you restore, you use the Oracle VM Manager refresh all feature. It's very important to know that you need to go to servers and VM tabs. You choose, in this case, server pools, and you may right-click with the right button, and after that you choose refresh all. This is a very expensive task, so you need to wait to be completed. And also, when you restore the Oracle VM Manager database, it's because you need to restore a database corruption or a problem with the database files. You will learn that, for example, if you have a major failure, okay, this restore operation is part of. But if you have only a failure related to the MySQL database problem, right? You have an issue related about this, you need to use basically this restore database script. You don't need to restore the entire environment, database, file systems, repositories, that's right, and so on. So it's important to know that you have the option to save time. Okay, so the point the mean time to recover the environment, okay, will be reduced if only a problem affects to the MySQL database. What about recovering the Oracle VM Manager components? We need to restore the host environment and the Oracle VM Manager software by using one of the following. Where maybe you need to recover all the file systems, all the system disks, and the U01 directory. This is, I repeat, for example, using the LVM, you have the option to create the snapshots, so it's easy to restore the snapshots. Or you have alternatively the option to reinstall the operating system and the Oracle VM Manager software. Remember, when you reinstall the software with the root installer, you have the option to provide the unique universal identifier of the OVM Manager that you are trying to restore. All right, so you need to record, you need to store this information if you take this other alternative option to recovering the Oracle VM Manager components. After that, we need to cache the OVMM, the OVM CLI, and the OVMM underscore MySQL services. We restore the Oracle VM Manager MySQL database and restart the services. And if you reinstalled the Oracle VM Manager software, we need to re-register the restored certificate information for the new WebLogic admin user with the OVM keytool.sh command. And you need to regenerate the certificates for the Oracle VM Manager user interface and the OVM CLI with the configure underscore client underscore third underscore login.sh script. Well, you have a detailed steps about how to do it so in the notes for this slide in the student guide. And the final step is to refresh all the objects in the database. So you have the refresh all option explained you before. Okay, that I repeat, it should be an expensive task, but you need to wait to be completed to let to data repository to update all the information that is needed about certificates, about the new installation or the restoration installation, because maybe you have some kind of discrepancies, all right? Well, about recovering the Oracle VM server, okay, the Oracle VM server is considered a commodity in the Oracle VM environment. Well, the Oracle VM servers are able to be running even if the manager is not available or the database is not available, right? It's important to let you know this. So what I mean is that they are able to be running and the virtual machines, they are able to be running too, right? So if the Oracle VM server fails, it means that maybe some of the VMs will not be available, but if you implement high availability functionality in a cluster server pool, because this server is member of a cluster server pool, remember that the VMs automatically are failover to the other VMs that are part of the same cluster server pool. Well, but if the server fails, you have the option to reinstall the software on the server. After that, you reapply the custom configurations, and you need to rediscover the Oracle VM server by using one of the management interfaces offered by the Oracle VM Manager, or using the user interface or the CLI. We need to add the rebuild Oracle VM server to networks, file servers, and SAN servers as needed, and we need to add the VM server to its server pool. Well, this is about reinstalling the software if, for example, you have no option to restore the Oracle VM server. For example, I repeat, the Oracle VM server, you have the option to implement the LVM implementation and to take snapshots to protect your installation. So it should be more easy to restore a snapshot than reinstalling the entire software on the server. Well, obviously, when you reinstall the software, you create new certificates and so on. So this is why you need to discover that, right? And in addition to this, you need to rebuild all the networks, file servers, and servers as needed to be able to do so. Well, it usually appears after it's reinstalled and discovered as an assigned server, all right? If you typically restore from a backup, from a snapshot, it should be appear again as a member of a server pool, but you need to refresh if you want, all right? But if you perform the reinstallation, it is discovered because it has a different unique universal identifier. It appears as an assigned server. So this is why you need to add the server again to its server pool. While backup and recovery of the server pool file system, as you know, you have the option to choose an NFS share or a LAN. In the case of a LAN, it's automatically formatted with the OTFS file system. And in addition to this, you know that it contains DB files with the catalog information about the cluster, about the OVM servers, and about the OVM server pool. If it's an NFS-based server pool file system, you create or you emulate something similar, so it contains files that are the .obs pool.fs and the obs pool.fs.image in this NFS share. So you have different strategies. First of all, the server pool file system is an important component of the cluster server pools. Without it, the server pool is no longer operational. But the servers will be able to continue running the virtual machines. But for example, properties related to the server pool, much like DRS or DPM policies about load balance or power shaving capabilities, and some other actions, for example, about extending the server pool and so on, they are not available because the cluster server pool is not available, right? So this is why it means that it is no longer operational. About backup, all server pool file system in your environment is very important, for example, after the server pool is created and after adding or removing an Oracle VM server from the server pool. Well, so if you use an NFS-based server pool because you have files, the most simple way to take a backup is to take a backup of these files. But for a LUN-based server pool file system, typically the LUN is a storage array, much like, for example, Oracle CFS storage appliance. So you need to use the utility that is provided by this storage array provider to create a backup. In the case, for example, of the Oracle CFS storage appliance, you have the option to create the snapshots for the LANs, and also you have the option to replicate the snapshots or to send the snapshots to a tape in tape libraries. Well, the strategies for virtual machine availability and recoverability, you have two different points of view. First of all, for example, if you try to take the backups with Oracle VM-centric strategy, so you enable ability for the virtual machines, first of all. So if the server goes down, you have the option, okay, to be failover on another server. Also, you have the option to backup the external storage used by the virtual machines. So if they use, for example, NFS shared mount points, or if they use LANs, or if they use virtual disks, okay, you need to backup this external storage, and also backing up the repositories that containing the virtual disk and configuration files for of these virtual machines. Well, for the external storage is backing up the LANs. You follow the same strategy as before. For the cluster server pool file system, you have in the vendor that provides the storage array specific utilities to do so. And for the repositories, you know that, for example, you are able to create the exports in these repositories through the different Oracle VM servers that are able to access this repository, and you should be able, with a client utility, to get access to these exports through the Oracle VM servers to take a copy of these different resources, virtual disks and configuration files, and send to the tape system, for example. And if you take a backup strategy that is guest-centric, what you do is to backup your virtual machines as they were physical hosts. So if you find, for example, in a virtual machine an Oracle Linux or a Red Hat operating system or Microsoft Windows, you need to follow exactly the same strategy as you have a physical server. So you have backup agents, much like with products Oracle Secure Backup or from other backup providers, that you can automate the backup of the operating system and applications and data that you have there. So for example, you have virtual machines that are for database software or core database software. So also you need to have the option to take backups for the databases with the RMAN utility. Also you have the option to protect, for example, with DataGuard, and it depends on the software. If you use WellLogic, for example, software, also you have a backup utility that helps you to take backups of your WellLogic implementation and to send to a type library, and to also implement the recovery and availability features that are offered by this application I explained you before. About the backup strategy for repositories. Repositories contain resources that can be divided into two categories: direct virtual machine resources, such as the configuration files and the virtual disk. So it depends on the repository. If an NFS-based server repository, you can get access externally to the server and take copies of these files. If, for example, is a repository that is SANS server-based, Fiber Channel or iSCSI, you have the option to use the tools that are specific for these SANS servers, these storage servers, or, for example, create NFS exports through the Oracle VM servers that they are able to access the repositories. And also it contains indirect resources such as ISO files and virtual appliances. So the same strategy as before, explained you before, okay, should apply. You can store indirect resources into separate repositories, so be aware of the cross-repository dependencies. That's right, so when you want to take backup of some virtual machines and the virtual machines resources are distributed between multiple repositories, you need to put focus exactly on where these resources are located, in which repositories to take the backups. What about repository level backup for NFS type repositories? We provide the NFS access from the NFS server to the host executing the backup. So in this case, you know that you have access to the NFS server externally, or if it's mounted, you have the option to create exports functionality in the Oracle VM servers to get access to the VM servers and to extract the contents of the repository. It depends, because you know sometimes depend on the network infrastructure and the DM set, the militarized zones that you have, the firewalls that you have, maybe you should be able to get access or not to some of the servers directly or not. For OCFS2 type repositories, you create a repository export from the Oracle VM Manager user interface or the Oracle VM CLI. This is the most typical implementation. And also you provide a resulting repository path to the host executing the backup. Because it's an export, you could use this host that is responsible to execute a backup to mount with this type NFS, this export that is offered by the Oracle VM servers that you created with the manager user interface or the VM CLI. And for this type of backup, you need to kiosk your virtual machines if possible. You know that you have the pause and the resume options in the toolbar for the virtual machines. So it's much like to take a backup that is consistent for your virtual machines resources. What about storage level backups for virtual machines with physical disks residing on storage arrays? The advantages is that the same backup procedure for all storage elements residing on the same type of the storage array, and you can use the snapshot technology when available, for example, to reduce the backup window. With Oracle CFFS storage appliance, for example, we are using this, you have the option to take snapshots frequently. Also, you have the option to replicate synchronous or asynchronous the content, so it's about the protection. And the disadvantages is that it may be difficult to identify which virtual machines must be kiosked before the backups. Also, file level restore may be challenging. Well, and guest-centric backup, it means that you try to take a backup of the guest OS, much like it's running in a physical server. So your backup and recovery strategy for your guests may include several techniques. It depends, but you should ask with your backup administrator to let you to identify how to do it. You can backup your Oracle VM guest as if it were a physical host by using a backup agent, much like the Oracle Secure Backup agents. Also consider system and application data separately for backup purpose. So different is to take a backup of the, for example, the boot, root, and many other mount points or file systems. In addition to this, is different. For example, you need to backup the Oracle Home software file system, or for example, if this Oracle Home is for the database, different techniques to, for example, take backups of the database, much like using Arman utilities. You need to set up continuous availability in your guest by using Oracle Maximum Availability Architecture. Well, this is a white paper that shows us how to protect the guest OS, the software that you render, using different technologies. For example, for the Oracle database software, you have the option to use a data guard, so you can send remotely the database transactions, the data, to another server that is separate kilometers of distance, right, to protect of any kind of disaster this guest OS data for these guest OS applications. What about protecting guest applications with maximum availability architecture? Is continuous application availability must not rely on the high availability and recovery features for the virtual environment. So you need to balance about implementing this technique, about, for example, how it affects to the performance, because it's not the same to have a database that, for example, implement as a primary and you have a standby database, for example, using DataGuard. And it's important to know that it's an addition. It doesn't replace your backup strategy. Okay, so maximum availability architecture, okay, is to add additional protection strategies to your default backup strategy. Well, the maximum availability architecture is a framework for integrating various Oracle products into a cohesive fault-tolerant business system built for continuous availability of Oracle and on-Oracle applications. Well, in this also you have, for example, for protecting storage for databases, you have ASM. For protecting databases, you have Oracle RAC 1. For example, protecting of databases of disasters, you have DataGuard. Also for protecting Fusion middleware software, okay, you also have, in this case, DataGuard for the Fusion middleware software. Also, you have the Oracle Clusterware to help you to implement a high availability functionality for the processes on applications that you want to protect with this failover functionality. And using the maximum availability architecture to implement a continuously available business system is the preferred solution for disaster recovery with Oracle VM. I'll explain you later in this lesson. Well, we have a quiz about which statements are true about the background and restoration of the MySQL database on the Oracle VM on your host. You must create a cron job to trigger a daily backup of the MySQL database. That's false. Remember, you have automatic backups for them. Backup files are rotated to keep 21 backups events. That's true. You must stop the OVMM and the OVMM_MySQL services before you restore the MySQL database. That's false, because we use the MySQL Enterprise backup solution, which takes online backups. So the best of this is that there is no disruption for the manager to working with the catalog. And the refresh of all the components in the environment is automatically triggered when the restore of the MySQL database completes. That's false. That's right, that's false, because it's not triggered automatically. You need to do this manually. Sorry, for the previous one, see, you must stop before you restore. That's true. Okay, I was speaking about that is not needed for the backup, but for the restore operation, you must stop the OVMM and the OVM_MySQL. So the correct answer are B and C. And that's all for the first part of this lesson. For part 2, start with the recovery scenarios. The first section of this lesson presents information about backing up and recovering elements of your Oracle VM environment. Well, the next topics illustrate recovery options for two mainly scenarios. That is, the Oracle VM Manager host is no longer available, and the Oracle VM Manager host and the Oracle VM servers are no longer available. These recovery scenarios introduce concepts that you can use when designing your disaster recovery strategy. Well, for the first scenario, recovering the Oracle VM Manager is about what's happening if you lost the Oracle VM Manager database. Well, in this case, you need to restore it from the latest backup. And to do so, you have the restore backup utility, right? If you do not have a valid backup of the Oracle VM Manager database, you can repopulate the information in the Oracle VM Manager database if the Oracle VM servers are operational, the subpool file system are mounted, and the Oracle VM servers in the subpools. The Oracle VM servers storage and networking infrastructure is intact, and you can obtain the unique universal identifier of the current Oracle VM Manager installation. So you see that you should be able to create a new database from scratch and to repopulate, getting this information of all your whole Oracle VM infrastructure. It remains intact, and you know which is the unique universal identifier of the Oracle VM Manager that you lost. That's right. Well, so the steps to rebuild the Oracle VM Manager environment: we reinstall the Oracle VM Manager software. Remember, you need to use the same UUID of the previous installation. After that, from the Oracle VM Manager user interface or the Oracle VM CLI, you discover one Oracle VM server for each subpool. Verify the network configuration. You discover the file servers and SAN servers and add the discover Oracle VM servers to the admin servers and access groups. You refresh the LANs with repositories on them. You present repositories to the Oracle VM servers and refresh their repositories to record their contents in the database. You discover the remaining Oracle VM servers, and you add the remaining Oracle VM servers to your storage and network configuration. These are the steps to rebuild this. And the other scenario, well, you have more detail about these steps obviously in the notes for the student guide. And the scenario 2 is recovering the whole Oracle VM environment. So in this scenario is to recover the Oracle VM Manager components and the Oracle VM servers. So you rebuild the Oracle VM Manager and the Oracle VM servers, and you recover the virtual machine resources. In this scenario, you assume that you have access to the storage elements of the previous Oracle VM environment. First of all, by reassessing the storage elements, if your storage is intact, by restoring virtual machine resources from backups. These resources include, repositories and physical disks that assign to virtual machines. You learned previously, for example, how to take backup of this, right? And through replication. For example, I told you before that with Oracle CFS storage appliance, you can replicate, so you should be able to restore the replica. Or, for example, restoring a snapshot, of storage elements to a new site. Well, the steps to rebuild the whole environment. We need to prepare the new host, and in the new host, we reinstall the Oracle VM Manager software on that host by using the previous unique universal identifier that you used before, right? After that, we reinstall the Oracle VM server software for X86 software on your new physical servers, and you restore access to the storage components. So this operation, what it does is to reestablish access to the repositories and the loans that are assigned directly to your virtual machines. After that, you discover the Oracle VM servers. It detects new hardware, right? A new OBS agent with new OBS password, the new certificates, right, and so on. After that, you reconfigure your networks. So what it does is to create new networks IDs. After that, you reconfigure the storage infrastructure, discovering NFS servers, recovering SAN servers. You create the new server pools, so a new cluster ID are assigned. You see that these are in bold to let you know that you have new values, right? So it's important to know, for example, when you restore the, files related to database information and so on, you have some files that they retain these old IDs for the network interfaces and the cluster, and they need to be updated or they need to be replaced, right? After that, you reclaim the repositories and you restore friendly names, and you verify that all virtual machine resources are available. Well, the importance of this, the network IDs. You see that each network is assigned a network ID. Here we are listing the network, so you have an ID, for example, for the virtual machine network. So in the virtual machine configuration file, the virtual NIC network assignment references a network ID. So you see when you make a cut of the vm.cfg file, the configuration file on a specific virtual machine, in the VIF, the virtual interface entry, at the end of the MAC address, you have a bridge and you have the network ID bridge that is exactly the same that the network ID assigned for the network that you created. If not, you need to edit and you need to replace with the new one. Well, recovering network information for virtual machines, you have two solutions. You retain the former network IDs we recovered in your environment, so you save the network information that is stored in etc sysconfig network dash scripts, the metadash asterisk, all the different files on your Oracle VM servers. So you have the option to restore the files, or the solution 2 is to update manually this information that you log or you retain before. So you see it's very important for you to have some kind of way to, in your backups, to get access to these files if you need to restore, or for example, if you want to edit manually. Well, more details we have in this slide, obviously, about doing so. And for cluster ID discrepancy after a recovery, before recovery, each OCFS type repository has a cluster ID that match the cluster ID for the server pool. Well, remember, with the mounted .ocfs2 -d, you have the option to get the repository ID and the server pool file system. Also, you have the option to get the cluster ID. Okay, you see that all of them has the same cluster ID, meaning that they were part of this server pool. After recovery, the cluster ID for the new repository no longer matches the cluster ID for the server pool. So you see that this is the repository, and this is the sevepool file system, but you see that they changed it. Okay, this doesn't match. Well, so it's important to know that now you need to be able to change it. Well, you have the tunefs.ocfs2 utility that helps you to update the cluster ID, okay, in these internal files that contains this information that you retrieve with the mounted.ocfs utility. Also, you have details describing these notes in this slide. Well, also reclaiming repositories with different IDs, different cluster IDs. Okay, after creating a new sevepool as part of the recovery process, we update the cluster ID with this tool, fsckey, the file system check utility, OCFS2, and you will list the new cluster ID and you will get the previous cluster ID. So after that, with the tunefs.ocfs2 utility is the way that you perform the update. Well, and finally, about disaster recovery concepts is the way that you have a data center with the Oracle VM infrastructure, and you have a clone of this data center, maybe in kilometers of distance, with exactly a similar or a copy of the same Oracle VM infrastructure. So we have site A that is active now. So you have repositories, SAN servers, you have VM servers, cluster sevepools, non-cluster sevepools, you have virtual machines, you have network resources, that's right, all of them configured. And you have all the site B, which is passive, that's right, with exactly another Oracle VM infrastructure, but the question is that this is a different installation because you have a different Oracle VM manager, you have different Oracle VM servers and different cluster or non-cluster sevepools. But typically you have exactly the same repositories and the same SAM servers configuration and contents because you implement replication. You see, you replicate physically disk to site B. So you replicate repositories and you replicate application and data disk, the LANs. All right. Well, so what's happened with the replication? You have in the repositories the IDs that they are identified, they are related to unique universal identifier that is exactly the unique universal identifier of the site I. But if you want this passive site, the site B, to be activated, the Oracle VM manager there in site B has a different unique identifier. So if you try to start or get access to these repositories and the LAN contents, for example, sevepool file systems, you will get a failure, all right? So you need to do something similar when you are restoring or you want to release the ownership and take the ownership of the repositories, and the same when, for example, you lost the sevepool file system and you want to update the cluster ID, that's right, and the unique universal identifier for the manager for this cluster ID, that's right? So reclaiming repositories at site recovery, the recovery site might not have the Oracle VM manager unique identifier used at the primary site. So after a failover, the repositories are still owned by the primary site, not by this other standby or secondary site. In this situation, you must perform additional steps to reclaim all repositories. You need to refresh the cluster ID, as I showed you before in previous slides. You mount the repository file system and you change the unique universal identifier in the repositories.obs repo file to none. And in the OVM CLI, we execute take ownership command and specify the repository ID and a sevepool. Okay, this is the most important to do it so, right? Well, which statements are true about networking information in your Oracle VM environment? When you create a network in your Oracle VM environment, the network is assigned a name and a unique network ID. That's true. When you create a network with the same name in a different Oracle VM environment, you get a different ID for the network. That's true. When you assign a virtual machine virtual NIC to a network with the virtual machine role, the virtual NIC is associated with the name of the network. With the name of the network or the name of the, in this case, the name of the network ID. So this is not correct, all right? So in this case, the correct answers are A and B. So as a summary of this last lesson, let's see about backup and recovery or disaster recovery concepts. In this lesson, you have learned how to identify the Oracle VM components to be backed up. You need to organize your job, your work, right? Identify these use guidelines for backing up the components. You perform Oracle VM Manager database backups and restore. You recover your Oracle VM environment, and you discuss disaster recovery concepts by examining an active, passive, the disaster recovery solution. And that's all for this lesson. Practice 7-1 Backup and restore the Oracle VM Manager database. In this practice, you perform a manual backup of the Oracle VM Manager MySQL database. You perform this backup outside of the automatic backup mechanisms, which backups the database every day. You then restore the MySQL database by using your backup copy. For tasks, the first one, we backup your Oracle VM Manager database. We access the Oracle VM Manager host by using the SSH command from a terminal window on your lab machine. So we open the terminal window, so minus, we provide the password, and with the SSH command -x, we get access to the OVM MGR01 host. Remember, password is Oracle. We access the directory where the script to backup the database resides on the OVM MGR01 Oracle VM Manager host. cd/u01 app Oracle OVM manager-3 OVM_tools bin directory. If we list the contents, you will get the name of the script, the backup database. The next step is to backup the database by using the backup database script. By default, the backup script stores the backup as a manual backup to avoid the rotation that takes place for automatic backups. The backup script prompts you for the admin user and its password. -w. You use the -w option to force the backup script to wait until the backup job completes. We need to provide the admin user, and the password, remember, is my Oracle 1. We wait for the output of the backup. You see that the job is started. You will see that also the name of the backup is manual backup, is no automatic backup, and also you have the date and the time for the backup. Well, after that, we get information about the backup job has finished. Note if you get a message about not enough disk space available in U01 app Oracle MySQL DB backup, access this directory and remove the other backups. Now we access the U01 app Oracle MySQL DB backup directory and we list the contents. And we get these directories. Note that the U01 app Oracle MySQL DB backup is the default location for the MySQL backups. This default is set in the etc ovmm sysconfig file. The backup script created a backup directory with the stream manual backup and the timestamp suffix. The U01 app Oracle MySQL DB backup directory also contains the ovm model export underscore date and timestamp.xml files. The automated backup process creates these XML files, which contain a list and description of all the objects in your Oracle VM Manager database. Next step is to display the contents of the directory that was created during the manual backup process. Well, next step is to restore the Oracle VM Manager MySQL database. In the Oracle VM Manager window, you see the command to stop the Oracle VM Manager services and the service that communicates with the MySQL database. So we type service OVM CLI stop. I'm sorry, I have a typo. The next one is service OVMM stop. We stop at the CLI. Now we stop the Oracle VM Manager logic server with the core Java application. You should spend a bit more time doing so. And the next step is to stop the OVMM_MySQL service. We need to wait for this command to finish. This is the typical best order to follow when we try to stop these processes, these services. And we stop the MySQL database service. Show us the shooting now. Well, we get a success message. The next step is to delete the database file in the U01 app Oracle MySQL data, except the auto.conf, my.conf, MySQL config, and the MySQL_upgrade_info. So we clean the screen and we move to U01 app Oracle MySQL data. We list the contents and we remove the app fw ip data 1 ib underscore log file 1 ib underscore log file 2 50 the MySQL, the OBS, and the performance schema. Next step, step 3, we initiate the database restoration operation. List the database backups directory to locate your previous manual backup. Again, we navigate to U01 app Oracle MySQL DB backup, and we list the manual backup. Well, we switch to the Oracle user and we execute the restore by using the restore database.sh script. Provide the name of the backup, including the date time suffix. Note that the name of your backup file is different from the name used in the following example. For my case, I'm going to use bash U01 app Oracle MySQL, OVM-manager, OVM underscore tools bin restore database.sh manual backup equals dash we type enter, and now you see you get this message, much like expanding the backup image, applying the logs to the backup snapshot, and so on. And we need to wait that we get a message about success done, and also you have information about the restore operation in the restore log. The restore operation rebuilds the database and also restores the Oracle VM key stores and certificates. Note, because you did not reinstall the Oracle VM Manager software, you do not have to reconfigure the certificates used for authentication. For information about the steps to perform after reinstalling the Oracle VM Manager software, followed by the restoration of the Oracle VM Manager database, refer to the section titled Restoring Oracle VM Manager in the Oracle VM Administrator Guide with this part number or later. Now we switch to the root user by exiting the shell for the Oracle user, and we restart the OVM CLI, OVMM, and the OVMM underscore MySQL services in the inverse order. So we exit, and now we execute the service OVMM underscore MySQL start. Is starting the database, we get successfully. Then you start the OVM, the Oracle VM Manager application, and the lobby server. We wait to get a message that was okay. Well, this service OVMM start should take less than a minute, and the next step is to start the OVM CLI utility. Well, note that the restart of the OVM service takes a few minutes to complete. Step number 4, we perform post-restore steps for the Oracle VM Manager database. We access the Oracle VM Manager user interface. This may take a minute or two after the restart of the OVM service. From your SSH with the -X in uppercase option season to OVM MGR01, we start the Firefox. Well, we check if we have this, so we invoke the Firefox with the -no-remote ampersand, and we enter the URL file as https://localhost. You have in the history is this one, localhost ://ovm/console/faces/login.gspx. Well, now we log as admin with password my Oracle 1. Next step, we may click in the servers and VMs tab. We select server pools in the navigation pane, and we click in the refresh all on the toolbar of the management pane. Only one job appears in the job summary pane. Well, we click the jobs tab and examine the jobs trigger by the refresh all operation. So we may click in jobs, and we have this job. Also, you will see all the different jobs that appear. Well, after that, you successfully restore the Oracle VM Manager database. Notice that the restore of the Oracle VM Manager database does not impact the only running virtual machine. Exit your Oracle VM Manager user interface season. May click on logout, and that's all for practice 7-1. Practice 7-2, we recover from the loss of the Oracle VM Manager database. In this practice, you wipe out the Oracle VM Manager database to simulate the loss of the Oracle VM Manager database. You then proceed through the steps to rebuild information in the Oracle VM Manager database. You recover the friendly names for some objects in the database. For this step, you search for the names of the objects in the latest OVM model export 0-date and timestamp.xml file by using the web browser. Note, in your production environment, you must use the documented state of your environment to restore your environment to the same specifications as those that were in place before the failure. These specifications include the list of admin and refresh Oracle VM servers for your NFS and SHAN servers, and the server pool assignment for all your virtual machines. Well, for the tags, we are going to first one, wipe out the Oracle VM Manager database. So we access to your Oracle VM Manager host season, or start a new season if necessary. We stop the OVM CLI and OVMM services. Remember that this step should take a few minutes. We access the U01 app Oracle OVM-manager-3 OVM_upgrade bin directory. We list the contents of the different SH scripts, and we have the OVM_upgrade.sh script. We run the OVM_upgrade.sh command, and we use the --delete db option to delete the contents of the database. We need to use the option described in the following table. Note that the password required is the password for OVS, not the password for the admin. If you have changed the password for admin, and after running your work environment for a while, this is likely to have been done, you must use the password that you specify during the installation of the Oracle VM Manager software, and not the new password for the admin. So following the data in the table, You see that also this MySQL server is not listening the default standard MySQL server port. 3306 is this other one, and this is the database that we want to delete. We execute the command and we initialize the process. So the database wipe was completed. All the Oracle VM Manager database objects are deleted, but the tables are left intact. Now we restart the Oracle VM and OVM CLI services from your Oracle VM Manager season. Well, remember that it should take a few minutes to complete this process. And service OVM CLI start. Well, step number 2, we re-establish the mapping for the certificates between the Oracle VM Manager application and the Oracle VM Manager user interface. So we access to the U01 app Oracle OVM-Manager-3 bin directory. We list the contents, and we need to run the configure underscore client underscore third underscore login.sh script. We execute the command, and we should get an output similar to the output that you have in the activity guide. But this command also should take a few time to be completed. And then we restart the Oracle VM Manager user interface service. And also it should take a few minutes to complete these tasks. Step number 3, we access the Oracle VM Manager user interface and discover the Oracle VM servers. We access the OVM mgr01.example.com by using the ssh-x command, and we start Firefox to access the Oracle VM Manager user interface at the HTTP localhost 7002 OVM console and log in as the admin user. Well, I've already done this before. So I provide the credentials. The login to the process start. Well, the main window appears. Well, you will see that similar to a new installation, the getting started pane is visible. We hide the getting start pane by using the collapse pane button to hide it, and we may click in the discover servers icon to start a wizard. In the Discover Servers window, we enter the OVS agent as the Oracle VM agent password, and we enter the IP address for your two Oracle VM servers: 0.2.101 for OVSVR01.example.com and 192.0.2.102 for the OVSVR02.example.com. These IP addresses are also listed in the etc host file on your lab machine. We may click on OK to trigger the discovery operation. The two Discover Oracle VM servers appear under the pool 1 subpool as shown in the following screenshot. Well, we need to wait for the Discover server job to finish, but we could be able to subpools to expand. And to show us the pool 1 with both servers. When discovering the Oracle VM servers, the Oracle VM Manager examines information about the current configuration present in the Oracle VM servers. The Oracle VM Manager discovers that the Oracle VM servers belong to a subpool that identifies this subpool by its friendly name. Note if you see the red X icon on pool 1 in the navigation pane, acknowledge any critical error visible in the events perspective to clear the error. So we go here, perspective drop-down list, events, and acknowledge all, and we may click on OK. And now you see that the red X icon has disappeared. Oracle VM Manager also discovered the networks to which the Oracle VM servers are attached and the LANs and NFS shares to which the Oracle VM servers have access. Step number 4, we verify the network configuration in the Oracle VM Manager user interface. We click the Networking tab. All the networks with their proper network channels has been rediscovered as part of the Oracle VM server discovery process. Note when discovering the Oracle VM server, the information in the meta-asterisk files in the etc sysconfig network-script directory in the Oracle VM server is used to repopulate the network information in the Oracle VM Manager database. There is a meta-asterisk file for each port or bond. The Oracle VM Manager extracts the network name, network IDs, and network channels from the meta-asterisk files. IP information for the ports is not always recovered. Next step is to examine the management network 192.0.2.0 and ensure that the Oracle VM server ports and the IP configuration is present. So we select the network and we use the edit button and we access the ports tab to display the port information. Quick move through the screens and make sure that the port for each of the OVM server is present and that the final window contains the IP address for each port. So you see you have a bond on OVM server 1, OVM server 2, which is the server, and the IP address on the subnet and the addressing as a static. Let me click on cancel if no changes are needed. Verify the network information for the VM_network. We examine the ports for each Oracle VM server and we verify that the IP configuration information is as shown in the following. So for the VMnet, we may click on the edit, we select the ports tab, and again we view that we use the Ethernet 1 port for OVS server 1, OVS server 2, static configuration, and this is the subnet with the Nextmax. We may click on cancel if no changes are needed. After that, we verify the network information for the storage_net and the herbit_net networks. If there is no port information for these networks, individually edit these ports by selecting one port at a time by using the edit function to assign its IP configuration. So for the storage, we may click on edit, we click on port, and we verify that we use the third Ethernet port with the IP addresses, the max, and the addressing as a static, and the herbit, exactly the same. We edit, and in ports tab, we check that we use the Ethernet 2 for each server with this subnet IP addresses, the Nextmax as a static. So it looks like fine. Step number 5, we reconfigure the NFS storage. So the file server and SAN server configuration is no longer present because the Oracle VM Manager database was wiped out. In the Oracle VM Manager user interface, we click the Storage tab and we click in the Discover server on the toolbar. Discover file server. In the file server parameters window, we enter the information as listed in the following table. Name is NFS_server. The access host IP address is 192.0.2.1 and description is NFS server on lab machine. We may click on next to continue. For our information, you can find this information by searching the OVM model export file as shown in the lab's activity guide. The next section in the admin servers window, move both of Oracle VM servers to this selection pane. May click on next to continue. and the file server goes through the discovery and refresh operations. In the Select File System window, select the checkbox next to the only NFS share. There is a repository on that share, and the repository is discovered when we click in Finish. So we click this, and we click Finish to complete the operation. Now we schedule a job that will do this. Step number 6, we reconfigure the iSCSI SAN server. The SAN server configuration is no longer present because the Oracle VM manager was wiped out. Because the Oracle VM servers that you have discovered still have access to the LANs offered by the iSCSI server, these LANs are reported in the Oracle VM manager user interface but appear under the unmanaged iSCSI storage array folder. When you configure your iSCSI storage, the LANs move to their proper location. We expand the SAN servers folder in the navigation pane, and we expand the unmanaged iSCSI storage arrays. Select the iSCSI volume group. The LUNs appear in the management pane. We select SAN servers and click the Discover SAN server icon. We use the information in the following table to configure the SAN server. The name of the server is iSCSI_server. Description is iSCSI server on OVM mgr01.example.com. Storage type is select iSCSI storage server from the drop-down list. And for storage plugin, we use the Oracle generic SCSI plugin from the drop-down list. The Discover SAN server window looks like the following screenshot after you have entered the information. Now we may click on Next. In the Access Information window, click the Create New Access Host. In the Create Access Host window, enter the IP address for the server that exposes the iSCSI LUNs. This is the IP address of the Oracle VM Manager host on the management network. In this case is 192.0.2.121. We added the default port of 3260. We may click on OK to return to the previous window. We leave the chat box deselected. We click Next in the Access Information window. In the Admin Servers window, move both Oracle VM servers to the selection pane. We click Next to continue. In the Manage Access Group window, select the default access group and click the Edit Access Group icon. In the Edit Access Group window, click the Storage Initiators tab. And on the Storage Initiators tab, move both initiators to the selection pane. Click OK to return to the previous window. On the Manage Access Group window, click Finish to complete the operation. The iSCSI LANs move from the volume group for the unmanaged iSCSI storage array to the volume group for the newly reconfigured iSCSI SAN server. Note that the reconfiguration of the SAN server takes several minutes to complete. Wait until the log is no longer present on iSCSI server before continuing. Refresh all LANs in the iSCSI server by selecting them and clicking the Refresh Physical Disk icon. So with the Shift key, we select from the first to the last, and we may click in the Refresh Physical Disk icon. Click OK in the confirmation window to refresh all 5 LANs. In the job summary pane, you observe that the operation refreshes each LAN. You can ignore the failure on refreshing the server pool file system. The system generated the error because the server pool file system cannot be refreshed. This is the failure. That should appear. You can ignore. Okay, and all of them are refreshed and are fine. Step number 7, we refresh repositories in the Oracle VM Manager database. Click the Repositories tab. All repositories are not showing. Expand repositories, but their contents are not available yet. So we verify that the 3 repositories are present to both Oracle VM servers. If necessary, present the repositories to the Oracle VM servers as needed. For example, iascasi_repos1, the repository is already present for both servers. So we check this and we say present and present. And we see that it's presented to both of them. The iascasi_repos2 present the repository to OVS as vr02.example.com. We repeat the same steps for this other. iascasi_repos2. We may click on the icon present, and for servers, we check that it's present to this one. Well, you see that is wrong, so we do this, and we may click on OK. And we schedule the job. And the other one, nfs_repos, is present the repository to both servers. So we choose this one, we make click on present and present icon, and we check in servers that is present for both of them. If not, we move to present to servers, and we may click on OK. Well, to present a repository to one or more DBN servers, we select the repository navigation pane and we click the present and present select icon on the toolbar. At the completion of this step, you have present each repository to both Oracle VM servers. Next step is to refresh all the repositories. For each repository, select the repository in the navigation pane, for example, the first one, and we may click the refresh select repository icon on the toolbar of the navigation pane or from the repository's circuit menu. This is the option, for example, in the repository circuit menu. And it was done. Another option is to select this and to make click in this icon, refresh select repository. We schedule the job and it was finished, and we repeat the same step for the other one. Well, after the completion of this step, you have refreshed the 3 repositories. Examine the objects in the iascasi_repos repository by expanding the repository to display its folders and selecting each subfolder to display its contents. For example, we're expanding the virtual disk subfolder. All virtual disks appear with their friendly names in the name column. So you see here for the iascasi_repos1, in the name appears with the friendly name. When objects in the Oracle VM manager don't reclaim their friendly names, you can search the OVM model export.xml file by using the UUID to locate the object's friendly name. Important: do not perform this step because you rebuild the environment again in the next practice. Step number 8, perform additional post-recovery steps. Click the Servers and VMs tabs, select Pool 1 in the navigation pane, and then select the virtual machines from the perspective drop-down list. Notice that iascasi_pvm1 is still running after the recovery of your Oracle VM Manager database. So servers, pool, virtual machines, and we check that it's running. Well, we move all non-running virtual machines from the unassigned virtual machine folder to the pool 1 subpool by selecting all of them from that location and dragging them to pool 1. If the pool dragging operation is not working for you, drag each virtual machine separately or use the migrate action. So in unassigned virtual machines, we select the first one to the last one, for example, with a shift key, and we move. Well, you see that, for example, we have in the option now to do a show. All together. I'm gonna try to repeat again. It works, yeah. Well, now that in your production environment, you may not want to move all virtual machines from the unassigned virtual machines folder to your server pools. Use the documented state of your environment that you gathered before the failure to decide which virtual machines belong to which server pools and if some virtual machines must remain in the unassigned virtual machines folder. Perform a backup of your Oracle VM and your database. In your production environment, you must create a new database backup. In your lab environment, do not perform the backup at this time because the backup that you create before wiping out your Oracle VM and your database is still valid. Click the Network tab to add a range of MAC addresses to your environment. Click the virtual NICs link. So in Networking tab, virtual NICs. There are MAC addresses already present in your restored environment. These MAC addresses are assigned to virtual NICs in your virtual machines. Select the range that can include one or more of the recovered MAC addresses. For example, select an end value of FF0000. Click the Apply Range button to complete the operation. The list of MAC addresses might differ in your environment. You can verify the list of reserved MAC addresses with the get vnic MAC ADDR range Oracle VM and CLI command as shown in the following example. Sorry, it's wrong. Well, after that, you exit the Oracle VM Manager user interface season and you close the Firefox window. Look out. And that's all for practice 7-2. Practice 7-3, recover the whole environment and reclaim the repositories. In this practice, you rebuild most of your Oracle VM environment. In the previous practice, you simulated a situation where the Oracle VM Manager database is no longer available and you have no database backup available for restoration. In this practice, you assume that most of your Oracle VM environment is destroyed and you rebuild with new Oracle VM servers, new sub pools, and possible new storage servers, but that the LANs or shares that contain the repositories can be restored from backup copies or from clone copies. For the first step, prepare for a recovery scenario by saving the meta asterisk file information from your Oracle VM servers. The network configuration for your two Oracle VM servers is the same. Therefore, you can save the networking meta files from one Oracle VM server only. From a terminal window on your lab machine, access the obsvr01.example.com server by using the SSH command. Open a new terminal. Password Oracle. Access the etc sysconfig network-script directory. And we list the meta files. Note that there are three meta asterisk files in the listing of files in the network-scripts directory. Transfer the meta asterisk files to your lab machine's root directory. Well, we have this problem about an inconsistency in the known host, so we need to remove the entry. No problem. If we have this problem, we need to edit the known host, and we need to look for this entry. So with dd, for example, we remove escape column w key q to save. So we repeat again the command. We type yes, and the password in this case is the password for your lab host. Ignore any error messages about reserve mapping check-ins failed. Wipe the contents of the Oracle VM on your database to simulate the reinstallation of your Oracle VM on your host. This is step number 2. Note when you reinstall the Oracle VM on your software, you specify the UUID of the previous Oracle VM on your environment if your plan is to reinstate the environment as it was before the failure. Because you wipe out the Oracle VM Manager database instead of reinstalling the Oracle VM Manager, the Oracle VM Manager UUID does not change. Access the window with the SSH session to your Oracle VM Manager host, or start a new session to Oracle VM MGR01 if necessary. I'm going to open a new window. Password is Oracle. Stop the OVM CLI and OVMM services. Service OVM CLI stop, and service OVMM stop. Remember that this second step, service OVMM stop, it should take a few minutes to complete. Access the U01 app Oracle OVM-manager-3 OVM_upgrade bin directory. cd u01 app Oracle OVM-manager OVM_upgrade bin directory. Run the OVM_upgrade.sh command with the --delete db option to delete the contents of the database. Note you perform this step in the previous practice titled Recover from the Loss of the Oracle VM Manager database. Refer to this practice for information about the parameters used with the OVM_upgrade.sh command. We execute the command, and the database wipe was completed. The Oracle VM Manager database objects has been erased. Restart the OVM and OVM CLI services from your Oracle VM Manager session. Service OVM start. Remember, this step should take a few minutes. And we start the OVM CLI service with this other command. Well, the next step is to access the U01 app Oracle OVM-manager-3 bin directory. And we run the configure_client_third_login.sh script. Well, remember that this step should take a few minutes to complete. And the next step is to restart the Oracle VM Manager user interface service. So we execute service OVMM start. Restart. Remember that this step should take a few minutes to be completed. Step number 3, we simulate the reinstallation of the Oracle VM server for X86 software on both Oracle VM servers. Warning: while halting your Oracle VM servers, make sure that you execute the halt command in the window with an active CSON to your Oracle VM servers to avoid halting the lab machine. Well, I'm going to open a new terminal window. And we connect with the obsvr02.example.com server. Password is Oracle, and we type halt. Okay, we should get return to the lab machine because the connection to the obsvr02 server is closed. We know that proceed right away to the next step. Do not wait for obsvr02 to complete the halt process. We open a new terminal for the next step to access the obsvr01.example.com and issue the halt command. So we open a new window. We connect remotely with the server and we type halt to hold the system. Well, we verify that both the virtual machines, the obsvr01 and the obsvr02, are no longer running by using the xmlist command from your lab machine. Well, you see that now, for example, in this screen, I get returned to the lab host. So we verify that only the Xen server, the domain 0, and the Oracle VM manager must be running. If the obsvr01 or obsvr02 is running, after 5 minutes, use the xmdestroy domain ID to terminate it. On your lab machine, access the OVS running pool obsvr01 directory. Move the current system.image for obsvr01 to system.image_saf. Move the clean installation image system.image_clean install to system.image. Start the obsvr01 virtual machine by using the xmcreate command. Note if you get an error about the whole flag scripts not working, re-execute the xmcreate. Next step is to access the OVS running pool obsvr02 directory. We list the contents. We move the current system.image for obsvr02 to system.image_save. We move the clean installation image system.image_clean install_2 to system.image. Start the obsvr02 virtual machine by using the xmcreate command. Okay, step number 4, we access the obsvr01.example.com and obsvr02.example.com and verify that it is clean installation for both Oracle VM servers. Note, if you get a connection refuse message, the Oracle VM server is still booting. Well, to access the obsvr01.example.com by using the SSH command. Password is Oracle. And now we use the ifconfig-a command and verified that only bound 0 and ATH0 are up, and only both 0 has an IP address assigned. Bound 0 has an IP address, and ETH0 is the only one that is up with the other. Note that the only configured network interface in this interface activated at installation time. Verify that the OCFS2 cluster stack is not loaded. You get this message, no loaded. Exit your system to obsvr01.example.com by using the exit command. And now we will repeat the previous 4 steps on svr02.example.com. config-i bound, we get that it has this, and this other is up and running, and we check with this service O2CB status that the TFS is not loaded. Step number 5, we reinstate the meta asterisk files on the Oracle VM servers. If necessary, we log into the obsvr01.example.com. And we access the etc system sysconfig network data script directories. And we copy the meta asterisk files that you saved earlier to your lab machine. We provide the password for the lab machine. Now we exit the system to obsvr01.example.com, and we repeat the steps A, B, and C on obsvr02.example.com to reinstate the meta asterisk file. So we repeat the example before, but for this server. Important, you must complete these steps before proceeding to step 6. Exit the system to obsvr02.example.com. Step number 6, discover the 2 Oracle VM servers. Access the OVM mgr01.example.com by using the ssh-x command. Start the Firefox system to access the Oracle VM and your user interface at this URL, https localhost 7002 OVM console. Okay, we have the history. So we type this. We log in as admin, password is my Oracle 1. Note if the login process returns to the login page, try to log in again. Similar to what you experienced in the previous practice, the main window of the Oracle VM Manager user interface displays the Getting Start pane because wiping out the database causes the user interface to act as if this is a new installation of the Oracle VM Manager software. Well, click Collapse pane button to remove the Getting Start pane and may click in Servers and VMs tab. Click the Discover Servers icon. In the Discover Servers icon, specify the OVM agent password, OVS agent in lowercase, and the IP addresses for both the Oracle VM servers, 192.0.2, 101, and 192.0.2, 102. Click OK to initiate the Discover process for the servers. Well, after we spawn the process, you will see that in the navigation pane, in the unassigned servers folder, you could display the two newly discovered Oracle VM servers. We should wait to let to appear the servers. Now we have obsvr01.example.com in the unassigned servers, and now it's discovering the obsvr02.example.com. We need to wait up to the lock icons disappear. Step number 7, we assign the network information for the Herbit network and the VM matching network. Unlike the previous scenario, when recovering from the loss of the Oracle VM Manager database did not require reassigning network configuration information. Recovering whole environment requires assigning the network information for the HB_net, storage_net, and the VM_net networks. In the Oracle VM Manager user interface, click the networking tab. On the networking tab, select the HB_net and click the edit selected network icon. Then click in the ports tab, and in the ports tab select both with Control key Oracle VM servers and click the edit ports icon. Well, in the edit port window, select static from the addressing drop-down menu and enter the IP and network addressing as shown in the following. Be careful with this. This is 102 because this is the OVS server 2. And this is 101 because this is the OVSVR01. Okay, be careful because maybe for you change the order. The subnet is 2 and the netmax is this other. Let me click OK to return to the edit network window. And we may click on OK in the edit network window to complete the operation. We need to repeat this operation for the storage_net and the VM_net networks. We use the following table to assign the IP and netmax addresses. So the next one is the storage. So we may click on edit, import. You see that this information is empty. With Control we select both ports. We may click on edit ports. Addressing we change to static, and for the storage we use 192.168.3.102 for the OVSVR server 2 and 192.168.3.101 for the OVSVR01, and for the netmax is 255.255.255.0 and 255.255.255.0. Well, we check again, that is okay. We may click on OK. And we may click on OK. And the next is the VM_net. We edit the network. Import. We select both ports. There is no information. We may click in the edit port icon. Addressing we change to static. And the IP addresses is 192.168.1.101. You check now that the first server is server 1. This is the next MAC. And 192.168.1.102. And this is the net mask. We verify again the information with the table that you have in the activity guide. And we may click on OK. And we may click on OK. So you have successfully synchronized the Oracle VM on your database with the current networking state of your Oracle VM environment. Step number 8, we recover the storage by discovering the NFS file server and the iSCSI SAN server. For these tasks, you use the Oracle VM Manager UI to perform the following actions: reconfigure the NFS file server, refresh the NFS file server, refresh the file system offered by the file server, discover the SAN server, add both Oracle VM servers to the SAN servers as admin servers, validate the SAN server, add the Oracle VM servers initiators to the default access group, and refresh the SAN server. But for reconfiguring the NFS storage, the file server and SAN server configuration is no longer present because the Oracle VM Manager database was wiped out. In the Oracle VM Manager user interface, we may click in the Storage tab and we select Discover File Server on the toolbar. In the File Server Parameters window, we enter the information as listed in the following table. Name is NFS_server. The access host IP address is 192.0.2.1. We leave the checkbox selected for uniform exports, and for the comments or description, NFS server on lab machine. We may click on Next. In the Add Admin Servers window, move both of Oracle VM servers to the selection pane. We may click on Next. The file server goes through the discovery and refresh operations, and in the Select File Systems window, select the checkbox next to the Only NFS share. There is a repository on that share, and the repository is discovered when you click Finish. So we select and we may click Finish to complete the operation. This operation performs a refresh of the NFS server and file system on 192.0.2.1 column/NFS repos1 file system. Reconfigure the iSCSI SAN server. The SAN server configuration is no longer present because the Oracle VM Manager database was wiped out. When you configure your iSCSI storage, the LANs move to their proper location. We expand the SAN servers. Further, in the navigation pane, we expand the unmanaged iSCSI storage array, and we select SAN servers, and we may click in the Discover SAN servers icon. We use the information in the following table to configure the SAN server. The name is iSCSI_server. The description is the iSCSI server on ovmmgr01.example.com. Storage type, we select iSCSI storage server from the drop-down list. For storage plugin, we select Oracle generic iSCSI plugin from the drop-down list. The Discover SAN server window looks like the following screenshot after you have entered the information. We may click Next to continue. In the Access Information window, we click the Create New Access Host icon. In the Create Access Host window, enter the first IP address for the server that exposes the iSCSI LANs. This is the IP address for ovmmgr01.example.com. We accept the default port of 3260. So this is the IP address, this is the default port, and we may click on OK to return to the previous window. We may click Next on the Access Information window to continue. In the Add Server Admin Servers window, move both Oracle VM servers to the selection pane. May click on Next to continue. In the Manage Access Group window, select the default access group and click the Edit Access Group icon. In the Edit Access Group window, click the Storage Indicator tab. And on the Storage Indicators tab, move both indicators to the selection pane. Click OK to return to the previous window and click Finish to complete the operation. In the Storage tab view of your Oracle VM Manager user interface season, the LANs appear for the X86 server SAN7. So now this finish, you see that appears the LANs. Step 11 is to create a subpool pool and add both Oracle VM servers to this subpool pool. So in the Oracle VM Manager user interface, we click the Servers and VMs tabs. And we expand the Server Pools folder in the navigation pane. When you discover the X86 server, the Oracle VM Manager detected a subpool pool file system on one of the LANs. This is the subpool pool file system that was in use in your previous environment. You need this LAN for your new subpool pool. Delete the unknown pool entry by highlighting it and clicking the delete icon toolbar. So we select, we may click on delete, and when you are asked for confirmation, you may click in the delete confirmation window. Click the create subpool pool icon on the toolbar, and in the create subpool pool window, enter the information as summarized in the following table. Subpool pool name is pool1, VM console key map, English United States, VM star policy, star on best server, secure VM migrate, do not select. We set up for the timeout for cluster 300 seconds. For the storage for server pool, we choose physical disk, and the storage locator is filled as result of search for the physical disk, and description is optional. Well, when filled with the values from the table, the window looks like the following screenshot. Click the search button to locate the physical disk that is to be used for this new server. In the select physical disk window, we select the cancel physical disk. We select the lio-org, one between parentheses, and we may click on OK. Then we may click on Next. So the server pool is created. Well, we need to wait to create the server pool, and in the next step we are going to add the servers to be the servers selected both Oracle VM servers to the selection pane. Click Finish to complete the creation of the new server pool. The Oracle VM servers are added to the new server pool. We are able now to monitor the pool and how they are moved from the unassigned server folder to the pool1 folder. In the step 12, we are going to reclaim the repositories. Now that we have a clustered server pool, you can reclaim the repositories. OCFS2 based repositories can belong only to a clustered server pool, except for those created on local storage. We access and log to the obsvr01.example.com VM server. I'm going to use one of these terminals. And we display the available OCFS2 file system by using the mountd.ocfs command. Note that you see each entry twice explained in the lesson titled Oracle VM Troubleshooting. If you are using multipathing, you may see the same entry 3 times. The repositories are on the following LANs: the dev mapper with this number for the ISCSI_repos1, and the dev mapper with the other number for the ISCSI_repos2. The server pool file system is on the following LAN, the dev mapper with this other number. Examine the cluster ID for the server pool file system under the cluster column. This is the new cluster ID for the server pool that you create in the previous tags title. Create a server pool and add both Oracle VM servers to this server pool. The new server pool, the new cluster ID in your practice environment is different from the cluster ID shown in this example. The cluster ID for the two repositories no longer matches the cluster ID for your new server pool. You cannot reclaim the repositories until you change the cluster ID for the repositories to match the cluster ID of the server pool file system. Note, if you have been able to release the ownership of the repositories before rebuilding your environment, the repositories will show not in use in the cluster column. You could then reclaim the repositories directly from the Oracle VM Manager user interface. The repositories will show up when displaying Show All Repositories on the repository tabs. However, in this practice, you simulate a recovery for where you did not have a chance to release the ownership for the repositories. Well, we display the list of mounted resources by using the d3-h command. Note that only the server pool file system is mounted. We use the file system check utility fschck.othfs2 command to update the cluster ID for the repository on the dev mapper with the ID which corresponds to the repository ISCSI_repos1. Reply yes when asked to recover the cluster configuration. Recover cluster configuration information in the running cluster. We type yes. But also you will see which is the old value. So it continue processing and it finish. Well, now we use the fschck.othfs2 command to update the cluster ID for the repository on the dev mapper with this ID which corresponds to the ISCSI_repos2 repository. So we repeat the same command. File system check.othfs2 dev mapper again we get the cluster ID that is different and we type yes for recovery. And this is the end of 7-2 part 1, and we will continue with the next part. Continuing with practice 7-3 part 2, the next step is to display the OTFS information for the file systems. So we use the mounted.othfs -d command. All OTFS file system, the server pool file system, and the two LAN-based repositories belong to the same running cluster. Note your cluster ID is different. In the Oracle VM Manager user interface, click the Repositories tab. Select the Show All Repositories option and expand the Repositories folder. Show All Repositories. The only repository that appears is NFS_reports in the list of repositories, so the Oracle VM Manager does not know yet that there are repositories on two ISCSI LANs. We click the Storage tab. We select the Share File Systems folder in the navigation pane. The two repository LANs are listed in the management pane. We select the two entries for the repositories, and we may click the refresh file system icon on the toolbar. So we schedule a job for doing so. Well, then we click the repositories tab and we examine the repositories available. So we go to repositories, and now you see that the repositories is populated with not only the NFS repos, in addition to these both iSCSI repos. All repositories are now available and owned by your Oracle VM environment, but their resources are not visible. We need to present the NFS_ repos to both Oracle VM servers by selecting the repository in the navigation pane and clicking the present and present select repository icon on the toolbar. We select this. In the present this repository to servers window, select the servers option and move both Oracle VM server to the present to server pools pane, and then we may click OK to complete the operation. Well, after that, we right-click iSCSI_repos1 and select Edit from the shortcut menu. On the repository tab, select pool 1 from the subpool drop-down list. Click OK to complete the operation. As part of reclaiming ownership of the repository for the pool 1 server, the repository is presented to both Oracle VM servers. Right-click iSCSI_repos2 and select Edit from the shortcut menu. So on the repository tab, select pool 1 from the subpool drop-down list and click OK to complete the operation. Okay, now select repositories in the navigation pane, and in the management pane, select all repositories and click refresh selected repository. So with the shift key from the first to the last, and we have the refresh select repository icon. All repositories are refreshed. The refresh operation makes the content of the repositories available for use. Now we expand each repository in the navigation pane and display the resources in each subfolder by selecting it. The following screenshot displays the virtual disk resources for iSCSI_repos1. Step 13. Verify that virtual machines are working properly after the recovery operations. Click the Servers and VMs tab. Select the Assigned Virtual Machines folder in the navigation pane. Select all virtual machines in the management pane and drag them to the pool 1 subpool in the navigation pane. The virtual machines are migrated to the pool 1 subpool. Note that you have difficulty migrating the virtual machines in bulk. Migrate them one at a time. Alternatively, select each virtual machine, click the migrate icon on the toolbar and select pool 1 as the subpool to migrate it. I'm going to use the drag drop functionality. Okay, going to try it again. Let's see. Okay, it seems it doesn't work. Okay, it doesn't work. So I could migrate one by one. With the migrate button. Migrate or move. Finish. Migrate. Pull 1. Finish. Migrate. Next. Subpool. Pull 1. Finish. Migrate. Next. Server pool, pool 1, finish. And the last one, migrate a VM to a different server pool, pool 1, finish. Select pool 1 in the navigation pane and select virtual machines from the perspective drop-down list. So now in pool 1, for the perspective drop-down list, virtual machines, and now you view that all the virtual machines are in the pool 1. Start the _PVM1. We select the _PVM1 and we make click on start. Clean up to complete the recovery process. Note this list is provided to you only as information. You don't have to perform the steps in the list. Perform a backup of your Oracle VM Manager database and click the networking tab to reserve the MAC addresses for your environment. And that's all for the practice 7-3.